Start. All right. Good day, everyone. It's me again, Ejiga Fisaljonugwa Lafemi. I'll be taking you through the multiplexer lab. So, as the multiplexer is a device that helps with data routing. It combines multiple signals into a single signal. It's mostly used in the area of data routing. You can use it for resource sharing, function generation, and it has a large array of use. So for this lab, we're going to be demonstrating how to use how the multiplexer works using our PCB board, our IC. So this IC is the SN74LS153N. That's the label of the IC or the IC barcode. So you can look up the IC and find the data sheets. It will show you how the IC is labeled and everything you need to know about the IC. So we're using a battery for this experiment. I'll be using a bunch of jumper wires for the experiment. So fast forward, let me show you something about the multiplexer. So this is the typical architecture of a 4x1 multiplexer. As you can see here, it has 4 inputs. It has 4 inputs ranging from I0 to I3. It has one output, that is Y, and it has 2 selectors, the S0 and the S1. Okay, so the devices will be needed. I've explained that. Okay, so this is the typical architecture of the 74LS153N chip. So if you look at it, we have 16 pins. We have pin 1, pin 2 down to pin 8. We have pin 9 down to pin 16. So pin 1 is one of the G's and pin 2. So this is not your typical 4x1 multiplexer. So this is a double 4x1 multiplexer. So this is a 2-in-1 multiplexer. So you can either choose to use this side of the chip, or you can decide to use this side of the chip. So depending on the one you are using, you activate ground for the one you are using. If you are using the left part of the chip, you activate ground 1. If you are using the second part of the chip, you activate the other part. Then the last pin here, that's pin 8. Pin 8 is the ground. Pin 16 is the VCC. So without further ado, let me remind you again about how the input looks like. So for the PCB board, we have the input. You have B0, B1, A0, and A1. So these are the switches that represent these inputs. You can see the switches on the PCB board here. So each of the switches is well labeled A0, A1, B1, B0. So these are the switches here. So you have the output. The output ranges from S0 to S3. So that's where you see here, S0 to X3. Then the last pin on the output here is the ground, and the first pin on the input layer is the 5V VCC. So let's start. Before we start, our normal thing is to first of all, let's verify if the board works. We have to verify if the board actually works. So what you do next is to pick up your PCB board. You connect it to the right side of your breadboard this way. You connect it to the right side of your board. Then you pick up your battery and you connect it to your battery to see if it works. Okay, so you can see, let me flip all the switches. Okay, turn them on. So we have a working board here. So the PCB board works. So what you want to do next is to turn off all the switches, then gently disconnect the PCB board and the battery. Disconnect it totally. Okay, so first of all, what do you want to do first? Let's place our chip on the breadboard. So to place our chip, you have to know something. You have to place the part that has the notch shape, that's the cap shape here. You see, if you come here, you see something like a cup, a notch shape. So we are going to be making it to face the direction where we want to place PCB. I want to place my PCB from this direction, so the notch is going to be facing this direction. So I'm going to place my notch here. So I'll put my notch, I'll place the pin on pin 45. Okay, so that's all good, you can see. So next thing is to we're going to be placing the PCB board directly on the breadboard. So the PCB board will be placed in between the right side and the left side of the board. So you can see this. Can you see? You place it this way. So when you're done with this, the next thing you want to do is to start our connection. First of all, what are we going to be connecting? We are going to be connecting our grounds. So remember, pin 8 is our ground, so we start counting 1, 2, 3, 4, 5, 6, 7, 8. So pin 8 is our ground, so connect it to the negative part of the board. You connect it to the negative part of the board. Then the next thing you want to do is to connect the ground on the board. So you connect this, connect it to the negative part of the board. Okay, so the next thing we'll be doing is to connect the VCC to the positive part of the board, and we connect the 5 volts here to the positive part of the board. Okay, so quick one, let's look at our architecture again. So we have sorted the VCC, and we have sorted the ground, the VCC pin 16 and the ground pin 8. So what we want to do next is to connect our inputs. The inputs is 1C0, 1C1, 1C2, 1C3. So we are going to be connecting this corresponding to B0, B1, A0, and A1. So what are we going to be doing? We will use long jumper wires. So we'll start connecting from here. Pin 6. So this is pin 6 here. So we'll connect pin 6 to B0. Then we'll go again. We pick the next jumper wire. We connect pin 5. We'll connect it to B1. Next thing we'll do is to connect pin 4 to A0. Then next step we want to take is to connect pin 3 to A1. So this way we have connected our inputs. All our inputs have been connected, so you want to make sure the wires are well connected and the connection is firm. So once you can ascertain that the connection is firm, so look at the chip again. Let's look at this architecture again. We've connected all this, so we want to connect our output. Our output is 1Y, right? So look at our output is 1Y, that's pin 7. So we are going to take a jumper wire from pin 7 here. We'll connect it to any of our outputs. So I think we should use our S0 as our output. Okay, so this is looking good now. So we've connected everything here. What we want to connect next is to connect our selectors. So pin 14 is our selector on the right hand part, and we have pin 14 and we have pin 2. So I'll pick up this wire and I'll look up for pin 14. So this is pin 14, this is 16, 15, 14. So I'll pick up pin 14 and I'll connect pin 14. Let me put it first in the positive part of the board. As time goes on, we can decide to switch it because it's a selector. Selector can be in high current mode or it can be in low current mode. So next thing we want to look for is our selector here, which is pin 2. So this is pin 2 here. I'll connect my selector here to the negative part of the board. So our final step here, since we've connected our output, we've connected our ground, our VCC, we connected the selector on the right hand part, we've connected everything. So now remember I said this is a 2-in-1 multiplexer, that is you can implement 2 multiplexers on this particular IC at the same time. So we have to determine which part of the board are we going to be using, which part of the IC are we using, the right hand part or we are using the left hand part. So since most of our input connection is coming from the left hand part of the board, so we have to enable ground in pin 1. So to enable ground, I'll connect pin 1 and I'll change it down here to the ground. Okay, so once I do that, next thing I want to do is to connect my battery. Okay, all right. So once I connect my battery, you should know our 2 selectors, one is in high current mode, the other one is in low current mode. Then all our switches are turned off. So let's see what difference it's going to make. I turn on one switch and we have a power. So irrespective of what happens here, look at it, the power remains. So these other ones that are switched, they are actually what we call don't care statements. They are X. Okay, so let's turn on this switch and let's try to flip the rest. You can see when we flip the other connections, we don't have any power at all. Okay, so let's try this again. Let's move this selector to the negative part of the board and let's try turning this on. You can see nothing is coming up and this comes up again. So when we turn this off, everything goes off. So let's try to remove this selector from the negative part of the board and let's bring this selector to the positive part of the board. You can see we have power supply already in all parts of the board. So that's because this selector on this other end is supposed to always be on this area. Okay, so let's turn this off. So for this experiment, you have something called a truth table. So you try to experiment according to this truth table. So you can put your selector A at low frequency mode, put your selector B at low frequency mode, and put your selector C0 at low frequency mode, and turn the rest and enable ground at low frequency mode and see what happens. Okay, let me try this first one here. So selector A is at 0. Let's put it at ground, that is low frequency mode. Selector B is in low frequency mode also. Let's say we should put C0 in low frequency mode. So C0 is our B0 here. It's already in low frequency mode. As you can see here, it's already in low frequency mode, so it's not going to bring out power at all. But what if we have let's say our selector input here, we have A is in high frequency mode. Let's bring A to be high frequency mode, and we have B to be high frequency mode. Let me bring B to be high frequency mode. You can see we already have power, because when the 2 selectors were in high frequency mode, when the 2 selectors are in high frequency mode, tendency that you are going to be getting high frequency on the board, irrespective of what you have there. It's always there as a tendency. So I hope you understand. I hope you take your time to practice. If you have any questions, you can reach out to me through the comment sections. You can like the video, you can share, and can subscribe to the channel for more videos like this. Thank you.